Hi students, in the last class we considered that leaching process and all-around process for the extraction of aluminum. Those two questions carries 3 marks. Next, in this class we discuss about the refining of the nickel, zirconium and titanium. That nickel can be refined by using the Mond's process. You have to remember that process name also. The process employed in the refining of nickel is an Mond's process. In the Mond's process, the impure nickel is heated in the atmosphere of carbon monoxide. Nickel is heated in the atmosphere of carbon monoxide at a temperature of 330 to 350 Kelvin, forms a volatile complex of nickel carbonyl, NiCO4. This is the nickel carbonyl. It is a volatile complex. To balance, use nickel and 4CO. That nickel heated in the atmosphere of carbon monoxide at a temperature of 330 to 350 Kelvin, a volatile complex. The volatile complex name is the nickel carbonyl. This is the first step. This step carries 1 mark. Then second step is nickel carbonyl. That volatile complex is easily decomposed. That can be easily decomposed when heated at a temperature of 450 to 470 Kelvin. If you heat at a temperature of 450 to 470 Kelvin, this volatile complex, that nickel carbonyl, decomposes to give the pure nickel. This is about the refining of nickel by Mond's process. Just you practice as it is. You write down as it is. Definitely you get 2 marks. The process name is Mond's process. Nickel is heated in the atmosphere of carbon monoxide. This one is carbon monoxide at a temperature of 330 to 350 Kelvin. Volatile complex name is nickel carbonyl. Nickel carbonyl easily decompose at a temperature of 450 to 470 Kelvin. We get to pure nickel. This is about the Mond's process. Next, you consider that one arcal process. Then second process is the one arcal method. This one arcal method used for refining of zirconium or titanium. This zirconium or titanium mainly contains oxygen and nitrogen present in the form of impurity. These are the impurity. Oxygen, nitrogen as the impurity associated with zirconium or titanium. Zirconium symbol is Zr, titanium symbol is Ti. In the zirconium or titanium contains oxygen and nitrogen as in the form of impurity. It is important for the competitive also. The impurity associated with zirconium and titanium or oxygen and nitrogen. To remove this impurity, the crude metal is heated in the atmosphere of iodine. In our syllabus, they are given Zr. The crude zirconium metal is heated in the atmosphere of iodine, in the evacuated tube, in the evacuated vessel with iodine, forms a volatile complex of zirconium tetraiodide, Zri4. Zirconium tetraiodide. This is called zirconium tetraiodide. Then this is the first step. Then second step is that zirconium tetraiodide, Zri4, is heated, that decomposed in the tungsten filament, tungsten symbol is W, at a temperature of 1800 Kelvin. That zirconium tetraiodide decomposed over tungsten at 1800 Kelvin to get pure zirconium. Pure zirconium. This is about the monarchical process. Each step carries a 1 mark. That zirconium or titanium mainly contains oxygen and nitrogen as the impurity. To remove this impurity, the crude zirconium or titanium metal heated in an evacuated vessel with iodine forms zirconium tetraiodide, ZrI4, zirconium tetraiodide. Then second step is zirconium tetraiodide decomposed over tungsten filament heated over 1800 Kelvin to get the pure zirconium. To practice these two steps, this is about the Van Arkel method and Mond's process. They ask either Mond's process or Van Arkel process for the 2 marks. You will practice as it is. You copy this one, you get the 2 marks for each refining process. Next, you consider other process. Let's consider the zone refining process. Just I explain the principle and by using zone refining which metals can be refined. Then procedure part you follow the regular notes. That in that zone refining, the impurities, the principle involved is impurities. Impurities are more soluble. Impurities are more soluble in molten state. Impurities are more soluble in molten state than in the solid state. This is the principle. Explain zone refining process. If they ask to explain zone refining process, just you write this much, you get 1 mark. Impurities are more soluble in the molten state than in the solid state. Then, by using this zone refining process, which metals can be refined? Means the metals which are used in semiconductors. The metals which are used in semiconductors, like that is of boron, silicon, germanium, gallium, or maybe of an indium. These metals, they can be purified by using zone refining process. They are the metals which are used in semiconductors. The metals used in semiconductor, commonly ultra pure metals. They use any type of the word. Ultra pure metals are metals used in semiconductors, namely boron, silicon, germanium, gallium, or maybe of indium. They can be refined by using zone refining process. This is about the zone refining. Next class we consider other refining process.